Hello viewers, welcome to my channel ITJ Olympiads and AP Physics with Ambarish. And today I've brought a very interesting video for all of you. I'm sure all physics teachers will like it and also many physics students would like it. So how many times it happens that you are able to make the equations and then after you make the equations you feel really lazy that oh my god, so much Bullwork and shabby work is going to be there and you feel lazy sometimes solving those equations. So uh, but it so happens that sometimes we do come across problems which have I mean the physics is not that complicated, but maths is getting out of hand. So do not worry, I've brought a very nice solution for all of you. But at the same time, a word of caution, the tool that I'm going to present is best suited for use by teachers. Students can once in a while use it because in IITJ you are expected to do everything by your own hand. But yes, for testing your hypothesis or testing your understanding of physics on a complicated problem, it's perfectly fine sometimes to use a mathematical tool. So with that word of caution, I'll straight away get into the tool that I wanted to present. And I have tried so many mathematical tools for doing my physics work, but this one is the best. I've been using it for about 10 years now, 10 years for now. And stay tuned till end. I'll also tell you how to get this tool for free for your academic use. Okay, so without much ado, I'll straight away get into the tool. And the name of the tool is Mathematica. The software is Mathematica. And I've put in some commands over here, so do not read the entire screen, just follow my lead. uh, in this is Mathematica, and here we need to input some commands and then we get output. For example, suppose I want to solve an equation. Then deliberately I'm not doing it here because I've put in so many commands. Actually it was getting hard on my RAM, so that's why I put all the commands. I'm not doing on the fly, but I'll show you some of the things on the fly. So suppose I want to solve an equation. You can readily understand this equation happens in a pulley and two block system. So 2mg minus t is 2ma. That's the first equation, and the other equation is t minus mg is equal to ma. And suppose I want to solve for t and a. So from this, if you just write this equation and just press shift enter, so you'll get this. This is the result that you get. Let me modify this equation a little bit. Suppose instead of 2, I suppose I do 1.5. Let us say I do 1.5 over here, and here also I do, let us say, 1.5. Okay, just to show you how it works. So now the equation will change and accordingly the solution should change, and this is what I'm getting. See, since I put a decimal number here, so that's why the result is also in decimal number. So tension and acceleration I have right away. Instead of 1.5, suppose I put 3 by 2. So I'm pressing 3 and then I'm pressing control forward slash for fraction and then I'm making it 2. And here also I'm making 3 control forward slash 2, and I'll get now the result in fraction. See how beautiful it is. Now suppose in rotational mechanics you have 4 equations and 4 unknowns. How convenient it is to just solve this equation. Little bit of syntax. If the set of equations is put in curly brackets and instead of equal to use a double equal to. So but the syntax reference is very easily available on the internet. So many guides are available. It's a very simple syntax only. So this is for solving the equations. Okay. Now how about solving an integral? So here I have put an integral. Here I have solved an integration. You can see integration of 1 upon under root of 1 plus 2x square dx. And if I just put this and then I press shift enter, and this is the output. It's again giving the same output because I did not change anything here. Now suppose instead of this I change this integration a little bit, or maybe I can do one more integration. Let us say I am inputting a fresh integration. So for putting integration in symbolic language, I am pressing escape, int escape, to get an integration sign. And let us say I am doing 1 upon, let us say, 2x square, 2x and control caret 2x square plus 1 and escape dd escape x to get this one, this type of x, and then I press shift enter. See, I'm immediately got the result of the integration, that is arc tan root 2x, tan inverse is arc tan. So how convenient is that? You can integrate complicated functions in a breeze. Okay, similarly here I have done a definite integration. So integration of from 0 to 2 pi sine x cos x minus pi by 6 dx. And this if I just press shift enter, this is the output of this line 45. So you get pi by 2. Suppose I want to do something on the spot, so let me do one integration, simple integration here. Escape int escape for integration sign, control hyphen for lower limit, let us say I want to do from 0, control 5 for the upper limit, let us say I want to do till 2 pi, and let us say this is I want to do it a simple integration of maybe sine x or cos x, something like that. Let me take, okay, let me take cos x, and let's say I want to square it. So control caret square cos square x. This is how it represents cos square x, so don't worry, it's not cos of x square. And then I do this, and let's see what we get. See, it's giving the output as pi. So you can integrate it very easily. I hope it was there in the frame. So integration of just one second. So we got integration of cos square x. Let me bring it in the frame. So here it is. I hope now it is in the frame. Yeah. So cos square x integration I've done on the fly. Similarly, I can also do derivatives. For example, I want to differentiate this function 1 upon root of 1 plus x square, and I want second derivative. So this is simple syntax for doing the second derivative. So I've written 1 upon under root of 1 plus x square x comma 2, and I've done the derivative, and this is what you get as the output. So let me just once again do shift enter. So and it is evaluated the same thing. If I want, I can try derivative of some other function, maybe. Let me take derivative of maybe sine of 2x. Let's do it sine of 2x. Just for illustration, I'm taking small simple functions, and let me take first derivative only. So if you just write comma x, it means the first derivative. uh, so you get 2 cos 2x. Or if you want, let us say third derivative or something like that, so you can do curly bracket x comma 3, and this will give you the third derivative now. So this is what you get as the third derivative of the function. So I'm not sure if it is in the frame. I hope it is in the frame. So just now I've done derivative of sine 2x, the third derivative of sine 2x. Okay, so I'm sorry if it was not in the frame. I cannot see it. I've set up the studio, but I'm not seeing it in the studio. Let me check in the studio. Yes, I hope it was there. Yeah, it must have been there in your frame, because I'm getting a lot of space below. Yeah. Now another thing we can do is we can solve the differential equations. So next line you can see this, solving the differential equation. Okay, this is the differential equation. Y double dash x means this is d square y by dx square, and y dash x means dy by dx. So d square y by dx square plus dy by dx plus y is equal to 0. You have to write this is the syntax part. So it's a function of x, so I'm putting x everywhere. So this is the differential equation, and let us say I have initial conditions. Y dash of 0 is 1, let us say, and y of 0 is 1. So let's say these are the initial conditions, and I want to solve the differential equation. So I need to solve yx as a function of x. Simple syntax, can take you, you can learn it very easily. And just then you press shift enter after inputting that line, and here immediately I have the solution. So uh, so if you want, you can let me try to modify this. So I got either minus x by 2 cos root 3 x by 2 plus root 3 sine of root 3 x by 2. So let me just try to change the coefficients a little bit, and let's see what I get. So instead of y dash x, now I have done 2yx. So equation has changed, so output is now grayed out. And let me again press shift enter to get the new solution. See, now I have the new solution. So y of x is e to the minus x into 1 plus 2x. Okay, so how convenient is that? You can immediately solve differential equations also, just like that. And then the next thing I want to illustrate is plotting the functions, various functions you can plot. So here it is plot of sine x from x varying from 0 to 2 pi, a simple plot I've drawn. So now just for illustration, let me modify this a little bit. So instead of, let us say, sine x, maybe I can do sine 2x, and maybe here I can put 2 sine 2x. So now let's see what do I get. So this is the function that I get. Or maybe I can do x plus sine 2x maybe. So let's try out x plus sine 2x, and let's see how we get. This is the new plot that. So you can plot any function, you can visualize any function, and not just static plots, you can also make dynamic plots. So that's what I'm going to show to you, how you can make the dynamic plots. See, this is the command. So I've done manipulate plot sine of x minus 3t. So this looks like a wave function, right? F of x minus vt, x varying from 0 to 4 pi and t varying from 0 to 1. So now I can vary time and x both. So this is at certain time, this is plotted, and I want to see how it looks like at a general time. So what I can do, I'll just press enter, and this is what I get for output. And now I can visualize this, I can animate this. So you get a plus sign over here, you just press this plus sign over here, and then you can just play this. So you can play, and you can see now this whole plot is animated, and you can see that it's going like a wave. If you want, you can speed this up or slow it down. Let's say I want to speed up, so I'll just press this, and now this graph, this gets speeded up. So you can very easily visualize what's happening. Okay, you can also change the time if you want to do it for a longer time, and you can also slow it down. If you want to slow it down, just keep pressing slower, 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 and you can play the animation both in both directions. Just press, instead of forward, just press it again, it goes backward, and then it goes forward and backward both. So once it will go forward, and then again it will go backward. So very convenient to visualize the variations of functions. We can add as many sliders as we want, we can have as many variables as we want, and we can see the variation of the shape of the function with respect to every variable. So here it's just a 2 variable function, you can make n number of variables, so no problem with that also. Okay, so I hope you like this feature. Then the next very useful feature, or I would say awesome feature, is that it can also play sounds. You can also generate sound signals, and you can visualize the sound, or maybe I don't know, visualize is something related to vision, maybe audiolize the sound. So here I have put a time, the function. So it is a double tone function. There's a 440 hertz frequency, and then there is also 441 hertz frequency, and all of us know that this should lead to a beat frequency of 1 hertz, right? So we should hear alternately loud sound and faint sound, and I am varying time from 0 to 5 seconds, because if I play for very large time, it will become irritating sound. Even for 5 seconds it might irritate some of you, but please bear with me. Just for demonstration, I'll play this sound for 5 seconds. So let me play this. Okay, let me just evaluate it once again. So no magic here, no trick being played here. So I've just evaluated this again, and let's see what happens. So I hope you are able to hear the sound. It's going up and down, up and down. I'll play it once more. So it's a signal of about 440 hertz, and which is going up and down, up and down. Okay, if I want, instead of 440 hertz, I can do it with some other frequency. Maybe I can do it with 880, and here also let me do it maybe 881. 881. So now it will be a shriller sound, but again it will be varying. The intensity will be, the beat frequency will be 1 hertz still. Okay, so let me play this one now. Quite irritating, let me stop it. Okay, so you can play around with it, and you can visualize sound any way you like. Okay, and then the next feature that you can do in this is you can make 3D plots. Desmos is another good tool, but the problem is Desmos doesn't have 3D plotting features, but Mathematica is great with 3D plots and all kinds of, I mean, if you spend a little time, it is worth the investment, and you can go to town with it. There's nothing that you cannot do with Mathematica that you can do with hand. Everything you can do as far as physics calculations are concerned. Just you need to train yourself a little bit with the syntax, but it's not very hard. So here I have plotted this function. So this is basically z is equal to x plus y square. So and if you want, you can turn this for visualizing. You can turn it in all kinds of ways. You can have different types of views. So you can right click to have a top view, so you can have a front view, you can have a default view, and you can also have a top view, and all kinds of manipulations are possible. So let me switch to default view, and let me, if I want to let's say just for illustration, let me change this function. Instead of sine of x plus y square, maybe I do sine of x square plus 2y square, let us say. And now I want to visualize what happens. So So this is what you get. You might be seeing that there is some jagged edges you are getting. There are options to control that, so that's possible, so don't worry about it. If you just yeah, if you want to know the syntax of anything, if you are not sure how to use that, you can also get the help readily. You can readily get the help on any function. Okay, let me just go back to the previous one. Suppose you know that plot 3D is the command, but you do not know how to use it, so you can just put a question mark and just put plot 3D and just 3D, D capital, and then you are getting the reference. So here is the help for this function. It's telling the syntax. So here you have to put function, you have to put x minimum to x maximum and y minimum to y maximum in this form. And if you want to see an example, you can just put a down arrow, you can get the help anywhere. So and then if you press on local, then it will open the local help page. If you press web, it will open the web page describing this command and will with a lot of neat examples. So very easy to learn this thing. Okay, so after plot command, there is also, you can also visualize field lines of a vector plot. So here, let's say my vector field is sin x I cap plus cos y j cap. So I can just plot that function and x varying from 0 to 2 pi. So you can very easily see that how the field lines are plotted. So if you know the field line function in I cap and j cap, you can very easily plot and see. There's also a function called vector plot 3D. In that you have to give 3 of these. So I have not included that command here, vector plot 3D, but I'm sure you can understand what that would do. It would plot a 3D plot, give you a 3D plot of the vectors. Okay. And these color codings, by the way, they reflect the intensity of the field. You can see the arrow color is changing. So a lot of options for visualizing. You can customize also. If you just take the help, you'll see there's so much customization you can do in these plots also. So I'm not exploring the options. This is the idea, is just to present to you the beauty of this software. Okay, so excellent software. Then some of you might recognize this plot I had used in my video on Doppler effect. I had done that using Mathematica. So I mean, if you learn a little bit of syntax, or even if you do not learn, you can very easily search internet for anything that you want to do with Mathematica. Some ready commands will be there. You can just customize it. So this is what a little more complicated syntax you can see. But through this I've generated this concentric, not concentric, Doppler kind of wavefront plots I have generated using parametric plot 3D. This is another feature you can see. Then you can also make very nice metallic looking graphics. So here I have again used parametric plot 3D and I have done material shading gold. So and tube 0.02 size. So this is what I've got, a Lysage's figure, a golden Lysage's 3D figure, and I can also rotate this any way I like. Let me evaluate this command fresh so that I hope it doesn't hang. Okay, let me evaluate this command afresh. And instead of sine 3x, maybe I change this to, instead of 3x, maybe I should do it 5x over here, and let's see what happens. Maybe I do 5x, and instead of tube size 0.02, I can take tube size as 0.03, and we'll see what type of plot I get now. See, so this is the plot that I've just generated. It's a different Lysage's figure, and if I want, I can get all kinds of views from this. So maybe I want to see the front view. So this is how it looks like in the front view. This is the front view. Okay, and I can generate all kinds of views. I can also rotate it in 3D. Okay, my system is a little low on RAM, so please bear with me. I'm not manipulating it that much so that this thing doesn't hang. And then this is another plot that I had done using this plot I had used. You might be remembering I had done a video on torus, and integral b dot dl was to be found from 0 to infinity. So I had done something like that. Some more 3D plots I have done using Mathematica. There was one regarding the proof of reciprocity theorem, mutual inductance reciprocity theorem. That plot also I had done using Mathematica. So just to just to generate your interest in this software, I've done a little bit of, I'm not getting any revenue from Wolfram people, so but still they're already doing a great job, so I have absolutely no hesitation in marketing Mathematica for on their behalf. I'm not paid by Wolfram, so that's the disclaimer, but it's a great software and I have been helped time and again by this. And now all of you might be wondering how to get this one. So it turns out that the Mathematica software, if you want to install on your PC, it's a paid software. And I mean, even though some nominal charge is there for students, but still it's a, if you want to use it offline without connection to internet, it's a paid software. But no need to get sad. There's a workaround. And uh, recently, I'm not sure when they launched it, but recently, not recently, sometime they have provided this service free of cost in their what is known as Wolfram Mathematica Cloud. Okay, so you can download this software. I'll just show you. So if you want to use on a laptop, you can just go to www.wolframcloud.com. This is the website, and there you can just sign up for basic plan, sign up for free. You sign up as a student, and whatever services are available for free, there'll be more than enough for all your Olympiad related calculations or JE oriented calculations. Actually, Mathematica is very powerful software. It's used in real time engineering also, and there they have very I mean heavy duty computational requirements, and they might be having to purchase paid plans. But as far as your Olympiad related work is concerned, JE related work is concerned, basic plan will be more than enough, and it is free of cost. You can use it. You can go to sign up, go to Wolfram Cloud and open a new notebook and start using the Mathematica syntax. So this is how you can use it on laptop. Then there is on Android also, it is this is available in Play Store. So you can just search for this app called Wolfram Cloud. You download this app and you sign up as a student, and then you can start doing all these calculations, solving and all. You can do it. And similarly on iPad also it is available on the App Store. If you go to the App Store, this is available. You search for the Wolfram Cloud app, and then again this will require, I mean, to use this you'll have to be connected to the internet, because this is going to do cloud computing. So whatever command you give it locally, it goes to the cloud and then it gets computed, and the output comes to your mobile device. But it's pretty fast. For most of your calculations it will take less than a second. Okay, so I hope this was a useful presentation for all of you, and uh, I felt very happy sharing this with you. I mean, Mathematica has brought me a lot of joy. It has helped me do a lot of problems from various sources. Otherwise, what would have taken days, it has helped me complete in hours. And I'm sure you too will have fun using Mathematica. And once again, for students especially, a word of caution: don't get addicted to calculating using Mathematica. You may use it once in a while if you are stuck with something very complicated, but try to develop the habit of computing things with your own hand. And generally for JE you won't come across very complicated things, but yes, if you want to accomplish, let's say you want to do a lot of problems in small amount of time, and you want to focus mainly on the physics aspect of it without worrying much about mathematical aspect of things, you can give it a shot. Okay, so with that I come to the end of this video. I hope you found my presentation useful, and if you found my presentation useful, please leave a comment in the comment section below how you liked my presentation, and share this video as much as possible with your teachers. With I mean, teachers can share it with their fellow faculty members, and students can share in their groups through WhatsApp, Telegram, or Discord, or whatever media you might be using for networking with your fellow students. And please do give a thumbs up to my video, uh, and uh, and if you have not yeah, most importantly, if you have not already subscribed to my channel, please do subscribe to my channel, because that's what keeps me motivated to do a new video every day. Unless there's some kind of emergency, I sometimes skip, but generally I do a video daily. So it's your support for this channel through your comments, your subscriptions. That keeps me motivated. So that's it for this video, and I'll see you in the next one. And as always, God bless you all. Thank you.